So here we are going to continue on the unit 2, lesson 7, and here we are going to have 5, and now we're going to speak about aldehydes. So what is an aldehyde? It is a compound with a carbonyl function. So I'm going to write it here. An aldehyde is a compound with a carbonyl function. So what is carbonyl function? It is very important that you know the carbonyl function. Carbonyl function. What is the carbonyl? It is a carbon with two double bond with the oxygen, and the carbon can have anything else. This double bonding, it is called carbonyl function. Okay, but the aldehyde has also an H here. Instead of having anything here, it has an H. So we have the carbonyl function and the aldehyde function becoming with the H. So this is the carbonyl, and the aldehyde function, I'm going to give it to you here. Aldehyde function. It is less than 1. See the carbonyl, you have it here, and you have an H, and you have here an alkyl group. Alkyl group, it is a mixture of carbons and hydrogens. Good, this is the carbon. Now naming. We're going to start to name, naming aldehydes. How they are going to name them? We're going to give some examples. One example, say for example, I have C here. C. I will have here the double bond, oxygen, a hydrogen, and this one it will be CH3. So how many carbons I have here? 2. So if there is not the O here, it will be, if it will alkyne, it will be ethane. So what we do to name it, this E here will be changed on al, nail, like that. And E will be changed to al. For alcohol, an E is changed to all. But for aldehydes, an E it is changed on al. Okay. Ethanol. Example 2. I have 1 carbon. I have double bond in here, a hydrogen here, and instead of having something, I have hydrogen. So this one, it is 1 carbon. It is methane with alkane. But what we're going to do, we're going to change the E with al. Methanol. Okay. Example 3. Example 3. Say we are going number of carbons. Say example 3. Say we want to name this one CH3. CH2, carbonyl, and H here, and we have CH3 here. So how are we going to name them? The same rules that we use it for alcohol, we use it for alkane, everything. First, the biggest chain, 1, 2, 3, 4, 5. So it will be pentane if it was an alkyne. But because it is an aldehyde, why it is an aldehyde? Because we have this function here, a carbonyl with the H. So this E become al, pentanal. But wait a minute, we have a side chain here. What this one is? Methyl. So what will be the complete name? First, we have to number our carbons. Here, there is no confusion. There is no ambiguity. The first one must be the 1 because always the function has the priority. And this one will be 1, 2, 3, 4, 5. And now it will be what? 4 methyl pentanal. For numbering the carbons for the aldehyde, there is no confusion. Why? Because aldehyde always it is in the end of the chain. It can never be in the middle. If it is in the middle, it has another name. It is a cetone, not an aldehyde. The aldehyde always it is in the end of the right end or the left end. That one. Okay. Now, what about the properties? To know the properties, only you have to say, what is the molecule, polar or non-polar? The aldehydes has the function like that are the carbonyl and the H. This one, it is a polar molecule. It doesn't have an OH group. So what are forces? The forces that it has, the intermolecular forces are dipole are the intermolecular forces. Okay. What is the prediction? The prediction, because dipole, the boiling and melting points, the boiling and the melting points, of aldehydes must be greater than the ones greater compared to the alkynes with the same number of carbons. This is the prediction, and it is true, this prediction. What we can say about aldehydes? Aldehydes, as we said, they are polar. They are used where they are used as solvents. In a wide range of application. Good. What we can say about aldehydes? For now, I think we said enough. Yeah, we said enough. Good. Good. I'm going to stop here.